well. Let's put the result in a temporary variable. And if we look at that temporary variable, we can see we can set its status code. For example, to 200, and then we just return our temporary variable. But this way of working can become quite cumbersome. ASP.NET Core contains a set of built-in helper methods on the controller that all create an iAction result. There's not found when a resource is not found, bad request when a request is malformed, and we'll encounter a few more of these. Let's change the action signatures to return an iAction result instead. First, let's try and get the city with passed in ID. If it doesn't exist, we return a 404 not found by using the not found method. Otherwise, we want to return a 200 OK containing the city in the response body. That can be done with the OK method, passing in the city. If an exception that isn't handled happens, the framework automatically returns a 500 internal server error. One of the other advantages of using these methods, rather than JSON result, is that the results aren't necessarily returned in JSON format. If we support other formatters in our API, the consumer can decide how he wants to see the results. We're covering that later on. Now we can also change the action above. Rather than returning a JSON result, we now want to return a 200 OK. There's no not found here because even an empty collection is a valid response body. The resource, cities, was found. It just happens to be an empty list. Okay, let's build and run and try that request from the previous demo again. So we'll send a GET request to API/cities/5. That request returned a null value previously, which wasn't correct. This time we do return the correct status code, a 404 not found. Before we end this demo, I'd like to cover one more thing. We've used Postman to create our requests, but as mentioned before, a browser is also an HTTP client that sends HTTP requests. Let's try getting a city that doesn't exist directly from the browser. We know this returns a 404 not found, but we have to open the developer tools to see this. There's an alternative we can use: status code pages. Let's open the configure method of the startup class again. ASP.NET Core contains status code pages middleware. If we add that to the request pipeline, a simple text-based handler for common status codes is added. We can add this by calling use status code pages on app. And let's try that again. That's already nice. Instead of an empty page, we get a 404 not found on an unexisting resource. And if we try our unexisting city, we get that same status code in text on screen. And this text message will also be visible in Postman. Whether or not you want to support this is up to you, of course. But if you want to do that, well, this is how. There's more to returning the correct status codes than what we've seen in this demo. Imagine working with child resources, i.e. the points of interest for a city. What's the correct status code to return if the parent city isn't found? And what's the correct one if the parent city is found, but the collection of points of interest is empty? Let's check that out in the next demo, returning child resources. In this demo, we'll combine what we've learned up until now to return the points of interest for a city, including the correct status codes. First, let's add a new class, Point of Interest TTO. And let's give it an ID, a name, and a description. Then, let's extend the City DTO class so it includes a collection of points of interest. It's a good idea to always initialize this to an empty collection instead of leaving it at null, as to avoid null reference issues. Typically you do this in the constructor, but we can use C#6's auto property initializer syntax for this as well. And we can also calculate the calculated field, number of points of interest. And let's add some dummy data to our data store for these points of interest. Let me just copy paste that. And there we go. Now we can add a new controller to look into that extra check we have to make. Let's add a new class and name it Points of Interest Controller. Let's make sure it inherits controller. And we can add the route attribute. Now we have to make a decision. If we want to allow access to the points of interest, regardless of the city, the route would be along the lines of API/points of interest. But a point of interest doesn't necessarily make sense without a city. It's a resource that's a child of another resource. So I like to reflect this in the URI, i.e. points of interest of a city should be accessible through API/cities/the city ID/points of interest. That means we start a controller route with API/cities. And then we add new actions. First, get points of interest. We decorate it with the HTTP GET attribute and pass in city ID/points of interest. This means that, combined with the route attribute, this action will be executed when a consumer sends a GET request to API/cities/city ID/points of interest. So we accept the city ID as a parameter. And this is where we need to check something else. We just learned in the previous demo that an empty collection shouldn't result in a 404 not found, because the resource can be found, it's just an empty list. In this case, however, we should return a 404 not found, more specifically when the city with passed-in city ID doesn't exist. Because in that case, the points of interest can never exist either. So we look for the city, and if the city is null, we return not found. If the city can be found, we return OK, passing in the points of interest. Likewise, an extra check should be added for getting one specific point of interest. We add a new action first, get point of interest. The HTTP GET attributes template this time contains two IDs, the city ID and the ID of the point of interest. We also accept these two as parameters. First, we try and find the city. You can just copy paste that. If the city doesn't exist, we return not found. Then we try and find the point of interest with the passed-in ID on that city object. If it's not found, we return not found. And otherwise, we return the point of interest with an OK200 status code. Alright, let's try this out. First, let's get the points of interest for a city that exists, the city with ID 1. And we get back Central Park and the Empire State Building, 2 points of interest in New York City. If we try a city ID that doesn't map to a city in our data store, we should get a not found. And indeed that's the case. Then let's try getting 1 point of interest. We pass in a city ID and a point of interest ID. And this works as expected. We get back New York City's Central Park. If we now change the city ID to 4, we again should get back a not found. So far so good. And we also get a not found if we try and get a point of interest for a city that exists but doesn't have a point of interest with that ID. For example, we try to get the point of interest with ID 10 for New York City. That doesn't exist. And indeed, a 404 not found. And if we select a single city, we should now get back the city, the amount of points of interest, and the points of interest themselves. And that's indeed the case. And with that, we've added support for child resources, including the checks required to return the correct status codes. But when we select the city, we also get back the points of interest. That's because we coded it like that. Our in-memory data store works with the DTO classes, and those contain points of interest for each city. The consumer of the API has no say in this, but as you know, later on in this course, we'll introduce Entity Framework Core. And that allows us to easily choose whether or not we want to load child entities from the underlying database. So at that moment, we learn how to let the consumer of the API decide whether or not to return the points of interest when requesting a city resource. Now let's have a look at the result formatting. If we look at the casing of the JSON we get back, we see we get it back in camel casing. The first letter is lowercased. And that's good. Most modern consumers expect this type of casing, like an Angular application. Property names starting with a lowercase letter. But if you happen to have worked with the old ASP.NET Web API, you'll know that this approach is different from what we're used to. By default, the property names were serialized as they were defined on our classes. In this case, that would mean with an uppercase first letter. So if you're creating a new API to replace an old API built with Web API, your consumers might expect the casing to be the same as how the property names were defined on the city class in this case. We can change this with the help of serializer settings. Let's have a look at that in the next demo. In this demo, we'll look into how we can work with serializer settings. ASP.NET Core by default deserializes from and serializes to JSON. But how exactly do we configure how that serialization happens? Well, remember that we can use the configure services method in startup. That's used to configure the services made available through the container. Well, we can configure MVC like that. Here we've added the MVC services. On that we can call add JSON options. This expects an action to set up these options. So we can add that with a lambda expression. From the options parameter, we can access the serializer settings. It's the contract resolver we're looking for. Because what we actually want to do is override its default naming strategy. By default, it's set to change property names, so they start with a lowercase letter. And we don't want that. So let's try and get that contract resolver. And let's cast it to a default contract resolver. I just had to add a using statement to use this default contract resolver. It was a using statement to newtonsoft.json.serialization. So in case this looks familiar, yes indeed, this is JSON.NET. ASP.NET Core uses JSON.NET by default for handling JSON. So now we've got the casted resolver and we want to access the naming strategy. And what we want to do here is set that to null. From this moment on, JSON.NET will simply take the property names as they are defined on our class. Let's give that a try. This is still the request from the previous demo you see on screen. So with a lowercase first letter for each property name. Now let's try and send that request again. And indeed, this time around, the first letter is uppercased, just as it's defined on the city class. As said, you might need this or you might not. I'm guessing that for most new applications, the default, i.e. a lowercase letter to start with, will be what's required. So I'm going to comment this out again. But like this, you now know how to access and manipulate the JSON's serializer settings. And that brings us to formatters and content negotiation. Somehow, the MVC framework must know what format to serialize to or deserialize from. And it does that with input and output parameters. The default format is JSON, but that's not always what we want. Let's have a look. A key concept when developing an API like this is that of content negotiation. This is the process of selecting the best representation for a given response when there are multiple representations available. When you're building an API that only your one client application has to consume, you might be okay with always getting back your representations in JSON format. But if you're building an API for consumption by multiple clients, some of which you have no control over, chances are that not all of these clients can easily consume JSON representations as a response. Some might be better off with XML or another format. The consumer can request a specific format by passing in the requested media type through the accept header. For example, if the accept header has a value of application JSON, the consumer states that if your API supports the requested format, it should return that format. If it has a value of application XML, it should return an XML representation, and so on. If no accept header is available, or if it doesn't support the requested format, it can always default to its default format. In most cases today, that's JSON. So we're dealing with output here. ASP.NET Core supports this via output formatters. An output formatter deals with output. The consumer of the API can request a specific type of output by setting the accept header to the requested media type, like application JSON. But if there's output, well, there's also input. We're running a bit ahead of ourselves with that. We don't provide input in a request body yet. That's what we'll do once we start creating and updating resources in the next module, coming up right after the next demo. So this does seem like a good place to mention this already, because next to output formatters, ASP.NET Core also supports input formatters. An input formatter deals with input. For example, the body of a post request for creating a new resource. For input, the media type of the request body is identified through the content type header. Let's see how we can configure these. In this demo, we'll learn how to work with formatters and content negotiation. By default, only the JSON input and output formatters are used. Let's have a look at that request for the list of cities we already have. We never passed in an accept header value, yet we get JSON back. Our API defaults to that. If we add application JSON as the accept header, and it's good practice to always add an accept header, because you want to be clear about what you want from the API. You might not have control over what the people who build the API might decide on as its default data format in the future. We should also get back JSON, as is indeed the case. Now let's request XML by changing the accept header to application/XML. And let's send that request again. And we still get back JSON. That's because no XML output formatter was configured. So the API just defaults back to JSON. We can change that. Let's open the configure services method of our startup class. Add MVC options allows us to configure the supported formatters for our API. Input formatter signifies the list of input formatters, and as you can guess, output formatters signifies the list of output formatters. The XML formatters are part of the Microsoft.ASP.NET Core.MVC.formatters.xml assembly. And what we're looking for is the XML data contract serializer output formatter. That's the one we want to add to the list of supported formatters. So we call add and we pass in a new instance of that XML data contract serializer output formatter. And as we learned, if you already know the name of the class you want to use, you can add a dependency like this through the integrated NuGet support in Visual Studio. Otherwise, you can also use the NuGet dialog. So I'm adding the package, and there we go. Likewise, for input, the XML data contract serializer input formatter can be used. Now, if you'd want to remove a formatter, like the default JSON formatters, you can use clear to clear all formatters or remove to remove a specific one. But let's not do that. We do want to keep on supporting JSON, right? Okay, let's build this, run, and try that request again. First, let's give it a try without an accept header. And we get back JSON. The default formatter is the first one in the collection. So far, so good. Now let's try it with an accept header. Application XML, and this time we get back XML from our API. And that's it for this demo, and it leads us nicely into the next module, where we'll learn how to manipulate resources. There we will use the content type header for providing the media type of a request body. But first, let's check out the module summary. We started out by clarifying the MVC pattern. Model View Controller. The model handles the logic for our application data. The view represents the parts that display data, which in case of an API, that's the data typically in JSON format returned from API calls. And the controller handles the interaction between view and model. This pattern leads to more reuse and better testability. We added the MVC middleware and learned we can use an HTTP GET to return data from our API. And it's routing that takes care of mapping a request URI to a method on our controller. Next to GET, there's also POST for creating, PUT for updates, PATCH for partial updates, and DELETE for delete. All of these are coming up right after this summary. For APIs, attribute-based routing is advised over convention-based routing. We also learned about content negotiation. That's the process of selecting the best representation for a given response. Technically, ASP.NET Core handles this with output formatters by looking at the accept header of the request which contains the desired media type. If input has to be provided, an input formatter takes care of that by looking at the content type header. And with that, this module is done. But we're currently just returning data from our controllers. Very few APIs only require that. Most also require the ability to manipulate data. Let's check that out in the next module.